Hi everyone, I'd like to take a look at an example in Maple, and the example that I'd like to take a look at here has to do with discrete logistic growth. So I've listed the assumptions here, and notice that I'm in text mode, so Maple is just operating like a word processor. So to use Maple like a computational tool or like a calculator, what I need to do is hop into math mode. So first, let's set k equal to 150. I used a colon equals in math mode, hit enter, and Maple spits back 150. In other words, if I were to type K in math mode, Maple would tell me that the value of that is 150. Okay, let's do the same for our parameter R. And I'll just confirm, okay, Maple understands that R is 1.5. And then lastly, let's set X sub 1 equals 100. Now, the next thing we need to do is to use this model. So for example, and I highly recommend doing this before you program a for loop, let's just do the next time step to make sure our formula is working. So to do X sub 2, I would do colon equals, and now according to the formula here, I need the previous value of X, so that would be X1 plus R times X sub 1 times parentheses 1 minus X sub 1 divided by K. And now let's make sure that that actually works. Okay, that gave me a number. And we could go through and play with, X sub 3 and so forth. But generally, we know that the formula works. We're not missing any parentheses or anything. It's much easier to debug code when you just have one line to troubleshoot. So now that I know my formula is working, let's add in here a for loop. So I'll say for n from 2 to 80. Do, and now the general formula is X sub n equals X sub n minus 1, R times X sub n minus 1, and up here X n minus 1. And then we need to end the for loop. So we'll say end do. And suspiciously, Maple prints out all these values. They all look pretty constant. So either we've got an error in our code or something strange is going on with the parameter R. So if you want to double check and explore the model further, you could choose a value for R like, 0.5. And you could see what would happen if R were 0.5. And here we have a slow climb up, but eventually we simmer out at 150. And so you might be thinking, why is it that we trend towards 150? What value up here in our assumptions tells us that that's where this population is going to land. But anyways, according to the directions, my task was to do 1.5 for R. And so I'll get back on task there. All right, so that will give you a little bit of a start for how to program the for loop. From here, the next thing you would want to do is create a plot. So if you have any questions about the plot, please let me know. I'll be happy to answer those in the forum.